Hello and welcome back. In our last session, we saw how operations management is the engine of an organization. Now, we're going to look under the hood at that engine's core components, its processes. Welcome to Unit 2, Process Management. Let's start with the big picture. Process strategy is the foundational blueprint for how a company converts inputs into outputs. This isn't just an operational detail, it's a strategic decision that determines your competitive capabilities, how you allocate resources, and where you invest in technology. This involves a fundamental trade-off. On one end, you have standardization, like Toyota's production system, which focuses on high volume and consistent processes to minimize costs through economies of scale. On the other end, you have customization. Think of a personalized Rolls-Royce, which offers flexibility and commands a premium price. Your process strategy defines where you sit on this spectrum. Now let's break down the common types of process strategies. First, we have the project process. This is for one-of-a-kind complex products like a custom building or a satellite. Each project is unique. Next is the batch process, used for moderate variety and volume, where production happens in discrete lots. Think of a commercial bakery making different types of bread or a company producing specialty chemicals. Then we have the assembly line, which we're all familiar with. This is for standardized products like automobiles and electronics, where resources are dedicated and tasks are performed in a strict sequence. Finally, for the highest volume and lowest variety, we have continuous flow, operations that run 24/7, like oil refineries or paper mills. Understanding these types helps you choose the right engine for the job. But the world of process strategy isn't static. Digital transformation is revolutionizing it. Modern technology is blurring those traditional trade-offs, enabling unprecedented flexibility and efficiency. For example, digital twins, virtual replicas of physical processes, allow companies like Siemens to simulate and optimize a process before ever implementing it, slashing reconfiguration costs. Adaptive automation, seen in Amazon's fulfillment centers, uses intelligent systems that can dynamically reconfigure workflows based on real-time conditions. And with IoT and analytics, companies like John Deere use connected sensors to gather data and continuously optimize field operations in real time. Once you have a strategy, you need to analyze and improve your processes. This is where process analysis tools come into play. Flowcharts are great for basic documentation and understanding the workflow sequence. Value stream mapping goes deeper, providing a holistic view that distinguishes value-added time from non-value-added time, helping you see the entire flow of material and information. Process charts allow for detailed documentation, quantifying the time, motion, and resources used for each task. And perhaps one of the most crucial tools is bottleneck analysis. The key insight here is simple but powerful. Any process can only move as fast as its slowest step. Identifying and optimizing this constraint is often the fastest way to improve overall performance. A primary goal of process analysis is to eliminate waste, and that brings us to the core of Lean principles. Lean is all about maximizing customer value while minimizing waste. A handy acronym to remember the 7 fundamental wastes is TIMWOOD. T for unnecessary transportation of materials, I for excess inventory sitting idle, M for unnecessary motion of people, W for waiting, idle time, O for overproduction, making more than is needed, O for overprocessing, doing more than the customer values, and D for defects that require rework or scrap. The goal of Lean is to systematically eliminate all of these. But what if your goal isn't just to reduce waste, but to achieve near perfect quality? That's where Six Sigma comes in. Six Sigma is a disciplined, data-driven methodology aimed at reducing variation and eliminating defects with a target of just 3.4 defects per million opportunities. It follows a structured 5-phase approach known as DMAIC, define the problem and customer requirements, measure the current performance, analyze the data to find root causes, improve the process by testing solutions, and control the new process to sustain the gains. The results speak for themselves. General Electric saved $12 billion in the first 5 years of implementation, saw a 70% reduction in aviation engine defects, and achieved a 50% reliability gain in its healthcare equipment. So to bring it all together, your process strategy is your blueprint. You have different process types for different jobs. Digital tools are changing the game. You can use analysis tools to see what's really happening, lean principles to strip out waste, and Six Sigma to drive for flawless quality. Mastering process management is how you turn a strategic vision into a reliably excellent reality. Thank you.